dark boundaries surrounding each cell before repeating the cycle. This process closely resembles the convection currents within the Earth's mantle, responsible for driving plate tectonics. This process is no joke. While on average it is estimated that each granule lasts for as little as 20 minutes, the flow within the cells reaches supersonic speeds of more than 7 km/s, generating waves on the sun's surface due to sonic booms. Fascinatingly, these granules can also be seen in the full disk view we saw earlier, utilizing the same wavelength of visible light. You may think this image looks quite grainy for such a high-tech space probe. And you're right, it does, but that graininess is the granules on the photosphere of the sun, not a processing effect or excess noise in the image. And that's it. Sadly, our journey ends here, as scientists have not yet figured out how to image deeper into the sun using either visible or non-visible light. Much of what lies beyond this layer remains shrouded in mystery, but we can see the benefits of using light of all different spectrums in our study of the sun. They help us observe exploding solar flares, vast coronal holes, swaying spicules, intriguing sunspots, and shape-shifting cells, just to name a few. In completely new ways, the sun is abuzz with lively activity, and so much of it would be invisible to us. Were it not for these imaging techniques, maybe one day we'll find ways to see deeper. Using techniques we can barely dream of currently, just like those ancient generations of humans long ago could hardly dream of the methods we're utilizing these days. But for now, just knowing there is so much going on unseen in the universe and knowing we have the means to uncover it fills me with excitement and curiosity. Who knows what else might be out there waiting to be found? If I were to tell you that the cycles of the sun could affect your entire life, you might think that I was suddenly taking a turn away from astronomy and into astrology. While there are many people in the world who believe that you can learn things about your future by studying the position of stars and planets, it's not a position I tend to take on this channel. I'm more interested in the beauty of space and the mechanisms that explain why it is the way it is, but sometimes there is a grain of truth behind even the most surprising of stories. So allow me to put on my prophesying hat. While I'm no writer of horoscopes, I will predict that, based on the current state of the sun, over the next few years, you might be more likely to experience bad health, less reliable technology, see warmer weather with fewer clouds, and possibly could be influenced in other surprising ways. How do I know? Because it turns out the sun, that giant ball of fire in our sky, is not just the place we get our energy from. Science is starting to show that its 11 cycles might just be the metronome measuring out how life on our planet ticks. I'm Alex McColgan, and you're watching Astrom. Today we're going to look at sun cycles in particular. I intend to show you exactly how the cycles the sun are already influencing the course of your life. It's no surprise that the sun is influential to life on Earth after all. In many respects, it is life's origin. Life on Earth needs energy to function, and the sun frequently provides that energy light for plants. Plants for herbivores, herbivores for carnivores, all the way up the food chain. It's hard to find anything on Earth that could live without our sun, but beyond the gift of that life, sustaining energy. It's easy to think of the sun as fairly static. We see it rise and fall in the sky, but we rarely notice it undergoing any sort of change. This, however, is an illusion. The sun changes all the time as science has advanced, and we've been able to shield out the worst of the sun's glare. It became possible to study the sun's surface as early as 1610. It became clear that the sun was a boiling, shifting sea of barely restrained plasma, which frequently wasn't restrained in spite of the intense gravitational force holding it all together. The nuclear reactions taking place in its core are so hot, reaching 15 million degrees C in its center, that plasma bubbles and bursts on its surface, erupting into solar flares that blaze in all directions. Sunspots, dark patches of the sun's surface that are filled with intense magnetic fields and can be between 1,600 and 160,000 kilometers across farm drift and vanish. Coronal mass. Ejections explode out of the sun's corona, the atmospheric zone above the sun that is strangely 200 times hotter than its surface. It's hard to find a place in the solar system that is as active as the sun. What many people do not realize is that activity waxes and wanes. The sun operates on an 11-year cycle that alternates between a period of low activity, the solar minimum, to a much higher level, the solar maximum, and then back again. Sunspots, solar flares, and CMEs all become more common during the solar maximum. You are 50 times more likely to see a solar flare during solar maximum compared to the sun's minimum. And large CMEs go from happening once every few days to multiple times in a single day. This is known as the Schwab cycle. Interestingly, this represents one half of a larger cycle known as the Hale cycle, which maps the changes in the sun's magnetic polarity. Once every Schwab cycle, every 11 years, the sun magnetic. North Pole and South Poles swap places when another Schwab cycle occurs. The poles swap back, tick, tick, tick. This constant rising and falling of solar energy levels thrums through our planetary system, rising and falling like